Hi, 5th and 7th period. So we're going to be talking about Lesson 20 in our workbook. Lesson 20 in our workbook is about parallel lines being cut by a transversal. So in this first page, and I'm on page 142 of your workbook. On page 142 of our workbook, they're trying to show us some of the angles formed when a transversal crosses two parallel lines. So in each one of these figures, L and M are parallel. So let's mark an arrow through L and M. This shows me that L and M are parallel lines. The transversal is this line P. A transversal is a line that goes through my parallel lines, and it creates 8 angles. So if you look at my picture, I have 1, 2, 3, 4 angles on the top line, and 1, 2, 3, 4 angles in the bottom line. Unique relationships are created when I cut two parallel lines with a transversal. So figure A is demonstrating what we call corresponding angles. Corresponding angles are formed when the transversal crosses the two parallel lines and they're in the same location. So for example, 40 degrees is in the top right corner of the 4 angles on line L. X degrees is in the top right corner of the 4 angles created on line M. The 40 degrees and the X degrees are considered corresponding angles, and as you might have already suspected, they are congruent. To save us some time writing, instead of writing the word congruent today in our notes, I'm going to be writing the congruent symbol. So corresponding angles are congruent. So I know this little angle right here would also be 40 degrees. The type of angles demonstrated in my second figure B is alternate interior angles. And I'm going to abbreviate angles with an angle symbol and an S from here on out. So alternate interior angles are just what they sound like. They alternate, or they're on opposite sides of my transversal, and they're on the interior, or they're on the inside of my two parallel lines. So these two are my alternate interior angles. And as you might suspect, alternate interior angles are also congruent. Moving on to the bottom two, let's do figure D first. In figure D, these are also angles that alternate, but notice that they are on the outside or the exterior of my two parallel lines. So their name is alternate exterior angles. And as you might suspect, alternate exterior angles are also congruent to each other. So in this particular one, X would be 125 degrees. So figure C is a different type of angle relationship. When two parallel lines are intersected by a transversal, if angles aren't congruent, then they're going to be supplementary. So in this case, these two angles are going to be supplementary. And I know that from their name. I'm actually going to call them same side interior angles. So these are same side interior angles. And just like before, their name describes where they're located. They're located on the same side of the transversal, and they're located on the interior of my two parallel lines. So same side interior angles are supplementary. And so for instance, this particular angle right here, these would have to add up to 180 degrees. And so this particular one would be 82 degrees. When you add those together, they would add up to 180 degrees because they're supplementary. So next page, let's look at some proofs for this. So these angles we'll talk more about, but right now let's look at why these angles are congruent to each other or supplementary to each other. So on 20.2 in your book, you'll need patty paper for this activity, ladies and gentlemen. We have, this is the wrong, oh no, I'm in the right place, sorry. So on this particular figure, we have two intersecting lines. So we are going to use a translation to prove some of our angles are congruent to each other. If you remember correctly, we can use our rotations, translations, and reflections to prove two triangles, two quadrilaterals, or two angles in this case are congruent to each other. So take your patty paper and trace out our two intersecting lines here. So here's point D, point B, point C, point A, and finally over here, yes, that guy was E. So as directions state, we're going to translate AE and CD by the directed line segment B to C. In other words, I'm going to move this so that my point B moves to my point C, just like we've been doing with figures in class. I'm literally going to move point B down to point C. And when I do that, you can visually see that I have created another set of line on this page, this line right here. This is what happens when I translate from B to C. I'm going to draw that line and I'm going to label it as A prime, B prime, C prime, D prime, and E prime. So let's draw our line. We're going to move it from B to C. So I'm going to draw a line through C. It's going to look parallel to the line above. And I'm going to place my points on there. Notice how A prime will be slightly ahead of A. E prime will be slightly ahead of E. So my E prime is right here. My A prime will be right here. B is moved to this point, and C is just moved farther down. So I notice C is about right here. I'll press through my paper. C prime is here. I also noticed, and I haven't discussed this yet, but D is moving down to B. So D prime would be here in my second figure. So take a moment and use your patty paper to slide your points down from C to B, and then put your new A prime, B prime, E prime, D prime, and C prime on your paper. So now, second question says, what is true about lines AE and A prime, E prime? So AE and A prime, E prime, I'm looking at them, they look parallel to me. And they are parallel because remember, when we translate a line, it is translated to a parallel line or itself. So AE and A prime, E prime are parallel because a translation moves a line to a parallel line or itself. In this case, it's a parallel line. And that's on our reference pages. So in part 3, we're going to start identifying angles that are congruent. So this is because we did a translation. So for example, let's take a look at this little angle, DBE. When I translate it down, it lines up perfectly on my angle that is D prime, B prime, E prime. Let's take a look at this. This is my angle DBE. And when I slide it down, notice it's on top of my angle that is D prime, B prime, E prime. That means that they would be congruent to each other, because if you translate, rotate, or reflect something on top of another shape or angle, they are congruent to each other. So, for instance, I can write that. This would be a geometric proof write-up. I can say that angle B is congruent. I'm sorry, I didn't use enough letters. Angle DBE, that was the one on top. Angle DBE from above is congruent. I'm using the congruent symbol to angle D prime, B prime, E prime. D prime, B prime, E prime, because angle DBE, that's the one on top, when translated by B to C lines up with angle D prime, B prime, E prime. So angle DBE is congruent to angle D prime, B prime, and E prime because angle DBE, when translated by B to C, lines up with D prime, B prime, E prime. That is a lot of stuff to write. Let's look at our picture one more time. I'm going to slide this down for just a moment. My angle DBE, when translated by B to C, so B down to C, lines up with D prime, B prime, E prime. So I can prove that those are congruent by translation. And those are examples of corresponding angles. Corresponding angles are in the same location relative to my two parallel lines. This is the upper right, this is the upper right. And I could use this same argument for my lower right angles, my upper left angles, and my lower left angles. So let's take a look at proving our angles congruent by a rotation instead of a translation. So in 20.3, we have a very similar figure. In this figure, we are going to use rotation instead. In number 1, it says to rotate line AE by 180 degrees around point C. Label the new image of A, B, C, D, E as A prime, B prime, C prime, and D prime. So let's grab our sheet and see if it lines up. It doesn't actually line up very well this time. Pardon me while I grab one more sheet. So I'm going to draw my figure on here. I have C, B, and D. And on this line, I have A and E. And it asked me to rotate by 180 degrees around B. So in this case, I'm going to around C. So I'm going to put my pen on C, and it doesn't really matter if you rotate 180 degrees this way. You can see your second line down below, or let me put it back to how it was. If you rotate 180 degrees clockwise, you get that same line down below. So no matter which way you rotate, we're creating a second line down below, which would be parallel to the first line. So let's sketch that line in. It's about right there, about right there. This then would be my B prime. That's A, so this would be my A prime. This is E prime. This is D, so I know that's my D prime. And I don't have a C prime because C was the center of my rotation. So this is now what my picture looks like, and I have these two lines that appear to be parallel. So let's take a look at number 2. It says, what is true about lines AB and A prime, B prime? This is my line AB, this is my line A prime, B prime. Well, they appear to be parallel, and they are because AB and A prime, B prime are parallel because, as we know from our reference sheet, a rotation takes a line to a parallel line. Sorry, I don't need that little point there. Line. So now it would like us to discuss congruent angles. So let's go back up and find some angles that would be congruent. We've got lots of options. Let me just start with the same angle that I was working with before. This is my angle DBE. Let's see where it ends up when I did my rotation. When I do my rotation about C, 180 degrees, it actually lines up down here. So it's underneath on this side. So my angle would be alternate exterior angles. So I know that angle, let's write this down, DBE, angle DBE is congruent to angle, in this case, we are going to call it E prime, B prime, D prime. You could call it D prime, B prime, E prime. Should we do that so our letters match? D prime, B prime, E prime, because when rotated 180 degrees around C, angle DBE lines up with angle D prime, B prime, E prime. Sorry about that. There you go. So for my geometric proof for this, I said that angle DBE on top is congruent to my angle D prime, B prime, E prime on the bottom, because when rotated 180 degrees around C, angle D, B, and E line up with angle D prime, B prime, E prime. These are alternate exterior angles. I wonder if this is true for my alternate interior angles as well. Let me get a different color. Let me put this back up here and try something else. I'm going to try this inside angle here. Let me rotate 180 degrees around C and find out where that angle ends up. I don't think I put it right at C, sorry. It looks like it's the other side of my transversal. Let's check that out one more time. You guys try it too. So A, B, C. Let's rotate that 180 degrees around C. And it looks like it becomes A prime, B prime, C prime on the other side of my transversal. So now I'm talking about my two alternate interior angles. So I could rewrite this sentence, changing my angle names for alternate interior angles. So let's try this. That was angle ABC. Let me slide this down. ABC. And it was congruent to angle A prime, B prime, C. Angle A prime, B prime, C. I'm okay if you call that C prime, but it was the center of our rotation, so it didn't actually move. Because when rotated 180 degrees around C, angle ABC lines up with angle D prime, B prime, and E prime. This is how you do a geometric proof for alternate interior angles or alternate exterior angles. You use rotation. And just recapping, on the previous page, we showed corresponding angles by using a translation, because those are two rigid motion transformations. Thank you so much.